All right, so we're looking at how to find a molecular formula. So our first step before we start to find the molecular formula is we're going to try to find what is the empirical formula. And your empirical formula is your more condensed version. It's the most simplified version. So for example, if you had like C2H4, this would be an example of a molecular formula. And the empirical formula would be what happens if you reduce all of these subscripts. So that would give you CH2. That would be your empirical formula. So the first thing we have to do is find our empirical formula from what's given to us in the problem. So we're told that it's 41.38% carbon. We're told it is 3.45% hydrogen. And it is 55.17% oxygen. All right. And so what we're going to do is we're going to assume that we have a 100-gram sample. So if we had a 100-gram sample, then 41.38% of 100 grams would give us 41.38 grams, and so on and so forth for the rest of our percentages. So we can replace those percentages with grams. So now that we have our gram values, we need to figure out how many moles of each of these elements we have in our compound. So in order to do that, we're going to divide each of these by their molar mass. So the molar mass of carbon is about 12.01 grams per mole. That's going to give us how many moles of carbon we have here. For hydrogen, that's about 1.01 grams per mole. And for oxygen, that's going to be about 16 grams per mole. So we're going to just go ahead and divide those through. So 41.38 over 12.01, that's going to give us about 3.45 moles of carbon here. 3.45 divided by 1.01 is going to give us about 3.42 moles of hydrogen. And 55.17 divided by 16 is about 3.45 moles of oxygen. All right, so these are just the steps you always take to find the empirical formula. You're going to find how many moles of each of the elements you have, and then you're going to say, you can remember this with a little saying. It's called divide by small and multiply to whole. All right. So you're going to divide all of these moles by the smallest amount of moles. So our smallest amount of moles is 3.42. So we're going to go ahead and divide all of these by 3.42. And this problem is actually a fairly easy one because they're all going to come out to be about 1 here. So we don't even have to do the last step. So since we have all about a whole number, they're all about equal to 1, we don't have to do that last step, which would be multiplying to a whole. So for example, if we had 1.5 for one of these, for example, we would have to multiply by some factor. So let's say we chose 2 until we found a whole number for all of these. So that would give you here 2, and here 3. And then you would use those in your empirical formula. But we didn't have to go through that issue for this problem particularly, since all these come out to be about 1. And so these are going to be your subscripts in your empirical formula. So you're going to have C1, H1, O1, or better written as CHO. All right, so this is going to be your empirical formula. But our problem here is asking for our molecular formula. So we're going to have to find what we have to multiply our empirical formula by, each of these subscripts in our empirical formula, in order to get the weight of the molecular formula. So we said our empirical formula is CHO, all right? And we need to figure out how much that weighs. So we know that's 12 for carbon, 1 for hydrogen, and 16 for oxygen. And that gives us about 29 grams per mole of this empirical formula. However, we're told in our problem that 0.05, that 5.80 grams is equivalent to 0.050 moles of our compound. And so let's divide this to find what the molar mass is. The molar mass is how many grams per mole we're going to have for this compound. So we're going to do 5.8 divided by 0.050, and that gives us about 116 grams per mole of our molecular formula. Now we have to see what we would have to multiply our empirical formula by, right? Because we're going to be multiplying these subscripts right here to get our molecular formula. So we're going to be trying to find what our molecular formula is, right? And I'm going to leave a little space because we're going to be putting in those subscripts. So we're going to use our molar masses to find this. Whatever we have to multiply our empirical molar mass by to get our molecular molar mass is what we're going to have to multiply our subscripts by to get our molecular formula. So we know that if we did 116 divided by 29, that comes out to be about 4. So we would have to do 29 times 4 to get our molecular formula's molar mass. So that's why we're going to multiply over here our subscripts by 4 as well. So that's going to leave us with C4H4O4, and that's your molecular formula.